Another major hurdle was to implement self-monitoring for safety-critical systems. Rate gyroscope applications frequently occur in systems that create a dangerous situation if the gyro fails without the host system detecting the rate sensing devices providing faulty information. Like in automotive stability control, brake systems generate the direction-changing brake commands independent of the driver. That's dangerous if something goes wrong with the system. For this reason, the safety system may become a totally unsafe system if it erroneously activates the brakes. Unlike other limited self-test, the gyro chip was embedded with a patented technique called CBET, continuous built-in test, which had the capability of monitoring end-to-end sensor and electronics health continuously during operation. And this was a major breakthrough for safety-critical systems. Now, the first high-volume production of the gyro chip, yaw sensor for lateral movement detection, commenced in June 1996 with the application of the Cadillac StabiliTrak system, and then Corvettes. An unexpected event in the fall of 1997 determined that the market would mushroom at rates that were multiple of 100% per year. This event was the loss of control and rollover of a new European vehicle by a Swedish automobile magazine editor. While executing a maneuver that is known as the elk test, which is to simulate the avoidance of an animal such as an elk crossing the road, especially on the Autobahn. The test showed that this car turned over. And this was a firestorm of adverse publicity. And in reaction to this elk maneuver episode, the manufacturer committed to fit all future vehicles with stability control. The European market, the manufacturer, seized this opportunity and decided to significantly ramp up their operations of stability control. The gyro chip demand for us skyrocketed by a factor of 10 to cover 400,000 units in the first year of production. We had not even learned how to crawl, let alone walk or run. And by 2002, we had shipped well in excess of 5 million gyroscopes. We had to learn how to walk and run at the same time. And with focused leadership and pioneering technical innovations, the gyro chip evolved from a single-axis yaw rate sensor to a fully packaged, complete automotive inertial measurement unit, meaning 6 degrees of freedom, roll, pitch, yaw, and acceleration detection in X, Y, and Z axes. And then we made inroads taking this technology to the aerospace and defense market. The thing that I want to mention here is we have a lot of scars on our back, but this is one of the greatest defense conversion stories that took place at that time. The gyro chip technology revolutionized navigation stability in aerospace and automotive systems. Its applications range from satellites to airliners and cars. It is in use worldwide in over 80 models of passenger cars for automotive stability and rollover protection systems, in over 90 types of aircraft, including the autonomous control electronics for the pitch stability control of Boeing 777 and the Stretch 77, as yaw dampers for over 3,000 Boeing 737 aircrafts, in most business jets for attitude, heading, and reference, and for guidance, navigation, and control in major UAV, missile, helicopter, and space programs. It's also the main technology for Rockwell Collins ProLine 21 avionics suites, NASA's Sojourner, the Mars rover,
Whoa.
EVA robotic camera, the AirCam Sprint, numerous satellites, and for Archer, the airborne hyperspectral imaging system used by Civil Air Patrol in search and rescue and disaster management missions. The redesign of this resulted in one of the most successful defense conversions, as I've told you.
Yeah.
And electronic stability control and rollover prevention are of paramount importance to human safety. And frankly, I have to say with great humility that thanks to our company and our efforts and our team that we enjoy when driving a car or flying on an airplane. By 2005, we had shipped over 55 million gyroscopes, and their use for stability augmentation in passenger cars has saved millions of lives around the world. So 2006, we got an unsolicited bid from Schneider Electric for all of BEI technologies. or rather in 2005 itself. We were
Hmm.
not looking for a sale, but it was the right time, and a sale took place. After which they wanted me to run their entire North American operations. I declined
Hmm.
after being very grateful. I already had a heart attack and had
Oh my
done
goodness.
very well with the sale. It was time for me to do some other things that I was really interested in. I started working and doing a lot of work for the National Academy of Engineering and joined my alma mater on the faculty of the Electrical and Computer Engineering Department. And that's where I'm not teaching, but I'm guiding graduate research in some very cutting edge technology.
Wow. Well, congrats on that. I mean, that's pretty spectacular and remarkable. No wonder you've amassed all these accolades. It's such a massive technology in so many different fields. Flying cars, I mean, flying airplanes, cars going around. If self-driving cars are going to work, it's going to be based with that technology everywhere. You can't
Without,
do it.
without, without this technology, you cannot have autonomous cars
You
because you
can't
need
have autonomous vehicles.
that's where you got the guidance from. And this was just one technology. I mean, we also developed the pointing system for the Hubble Space Telescope.
My goodness.
And we did. I don't want to get into it because that's a discussion all by itself, but
Yes, yes.
some very, very groundbreaking research. But that pretty much gives you an idea of at least one of these technology. And now I'm focused at UCLA on guiding doctoral and postdoctoral research in some very important areas, which is wearable, uh, non-invasive healthcare for detecting uh, human physiological conditions, including cardiac conditions. We're involved in computational sensing. We continue to work in miniaturizing inertial navigation systems, and we're involved in new forms of artificial intelligence and machine learning.
That's fantastic.